In this video, I'd like to take a look at solving exponential equations, specifically ones where the bases are not the same. Before we get to that though, let's review solving exponential equations where the bases are the same. For instance, if we had 4 to the 10th is equal to 4 to the 2x power, since these two expressions are equal, that means everything about them has to be equal. The bases are already equal. That just means I have to make sure that the exponents are equal. Since the bases are already equal, I just need to solve for 10 equals 2x, and I find out x equals 5. I can check to see whether I got that right by substituting back into the original. 4 to the 2 times 5 would make 4 to the 10th, which is what the left-hand side says also. So I know I got that right. Well, what happens if the bases aren't the same? For instance, this problem where 4 to the 10x minus 4 is equal to 64 to the 2x. The way you approach this problem is to manipulate one or both of the bases so that they are the same. In this problem, I'm going to choose to work with the 64 because I know something about the powers of 4. And I'll write that what I know down about 4 right over here. I know 4 to the 0 is 1, which doesn't help me. 4 to the first is 4, also doesn't help. 4 squared is 16, but 4 to the third happens to be 64. So what I'm going to do is replace that 64 right there with 4 to the third. So I didn't modify my left side of the equation, so I'll leave it alone. And in parentheses, 64 is 4 to the third. So just substitute and don't lose my 2x power. At this point, I just need to simplify the right-hand side by using the power of a power rule of simplifying exponents. So that's going to be 4 to the 10x minus 4 is equal to 4 to the, and the power of a power says you should multiply exponents if you have one outside parentheses, so that would be 3 times 2x, which is 6x. At this point, I've got the same bases. I just need to set the exponents equal and solve. So 10x minus 4 is equal to 6x. Moving the 6x to the left-hand side of the equation and the negative 4 to the other side, I end up with 4x equals 4. And solving for x, I get x equals 1. Now, I can verify this again by substituting. So if I take my original equation and substitute a 1 for the x, I'll end up with 4 to the 10 times 1 minus 4. Hopefully is equal to 64 to the 2 times 1. So simplifying that down, I get 4 to the 6th equals 64 squared. Now I just need to make sure, does 4 to the 6th really equal 64 squared? And that's pretty easy to verify. So 4 to the 6th power is 4096. 64 squared is also 4096. A couple alternate ways to do this problem. If you go to the calculator and enter actually solve any equation this way, no matter if it's an exponential or linear, quadratic, whatever type. If you enter the left-hand side into y1, so 4 to the, and it's important to put the exponents in parentheses if they're an expression, 10x minus 4, and in y2, enter the right-hand side of the equation, 64 to the 2x power. One way to go about solving this is to look at the table. So I go second graph. I see right there when x is 1, the y values are the same. So I know that x equals 1 is a solution, just like we found algebraically. Another method is to actually graph what we entered into y equals. That method is usually a little bit more difficult, especially dealing with exponents, because 4096 is such a big number to locate on the table, or excuse me, on the graph. Plus, a lot of times exponentials take a long time to graph on a calculator. Now that I'm finished, I need to modify the window. And since we already know that 4 to the 6 and 64 squared is 4096, I'm just going to change my y max to 4100. And I know my x value is supposed to be 1, so this window works for us. So if I graph, hopefully the resolution is good enough where I can see them cross. So somewhere in there I know they crossed. So I'm not going to zoom out and take time to do that, but if you all solving equations with the graph works the same way, you just find where they intersect. So that would be second trace. And I want to find number 5 where they intersect. Calculator really doesn't need my guess on the intersect, so I'm just going to press enter. And hopefully it's going to find 1, 4096. And there it is.